Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electrical machines, basically the basic introductory concepts related to electrical machines. So far we have discussed some basic concepts in the previous videos. In this video we are going to discuss some important properties, some important parameters associated with magnetism or the magnetic effects of electric currents, electromagnetism. Okay, so there are some basic terminologies, the definitions, the formulas which we should be aware of, we should have a basic understanding because they will come up in our discussion related to electrical machines. So first is, we have already discussed this, but let's go in a systematic way. Magnetic flux, phi through any surface which is placed in a magnetic field, any material or object, which is basically the number of magnetic lines of force crossing through the surface normally. So let's say we have a surface area A with A vector as the area vector perpendicular to it or normal to it, away from it, directed away from it, and it is placed in a magnetic field. The number of lines passing through the surface, that is the magnetic flux. Now it is related with magnetic flux density as the flux being the dot product of the magnetic flux density and the area vector, B vector dot A vector. Or we can say that the magnetic flux density B is the magnetic flux per unit area. That's when theta is equal to 0, then cos 0 will be 1 in that case. So this is the magnetic flux, the number of magnetic lines of force crossing the surface area, and magnetic flux density is the magnetic flux per unit area. Okay, so this is the relationship between magnetic flux and magnetic flux density. The SI unit of magnetic flux density is Tesla or Weber per meter square, where the SI unit of magnetic flux is Weber. So this is magnetic flux density. We have already covered it, that's why I am not going into detail about it. Next is magnetic permeability. Okay, this is also related to magnetic flux density. Now we know that whenever an object or a material is placed in a magnetic field, magnetic lines of force pass through it. Okay, now depending upon the nature of the material, how many magnetic lines of force they pass through that material, that depends on the parameter called as permeability. Okay, which is basically, we can define it as the material's conductivity for magnetic field lines. Greater the permeability, greater number of magnetic field lines pass through it. Smaller the permeability, fewer magnetic field lines pass through it. So we can compare it with the electrical circuit as resistance. Okay, so resistance means the more the resistance, less electric current, then smaller the resistance, higher the electric current. So like that. So magnetic permeability is the conductivity for magnetic field lines. Now we know that the number of magnetic field lines passing per unit area, that is given as magnetic flux density. So we can say permeability gives us information about the magnetic flux density. So greater the permeability, greater the magnetic flux density. It is a measure of the magnetic permeability of the material also. So how can we define magnetic permeability? So there are two ways in which we can express it. Let's say when the material or the object which is to be magnetized, it is placed in normal conditions, in vacuum or air. In that case, the magnetic flux density is B subscript 0, which is the absolute case in vacuum or air. That is the magnetic flux density in case of vacuum or air, B0. And let's say then the vacuum or air is replaced by a material, any material. In that case, the magnetic flux density of the material becomes B. So there are two kinds of permeabilities. First one is relative permeability and next is absolute permeability. So relative permeability of a material is the ratio of the magnetic flux density on that material, which is B, and then the magnetic flux density of the material if it were replaced by vacuum air, that is B0, B by V0, magnetic flux density of that material and magnetic flux density of vacuum or air, that is the relative permeability. So here vacuum or air, that is the reference with respect to which the permeability of all the other material is measured. Another way is to express relative permeability is the ratio between the permeability of that specific material to the permeability of free space, vacuum or air. Or mu r is mu by mu 0, where mu is the permeability of that specific material, any material x, y, z, whatever it is, divided by mu 0, which is the absolute permeability of vacuum or air, which is 4 pi into 10 to the power minus 7 Henry per meter. Okay, so there are two ways in which we can express permeability. First, in terms of magnetic flux density, which is the magnetic flux density of that material divided by the magnetic flux density of free space, vacuum or air. That is the first way. Second way is in terms of permeability, which is the permeability of that specific material divided by the absolute permeability. Okay, so these are the two ways of expressing magnetic permeability. Magnetic permeability basically is conductivity for magnetic field lines. More permeability, more magnetic field lines of force; less permeability, less magnetic field lines of force passing through the material. Okay, so this is permeability we have covered, flux density we have covered. Next is magnetizing force or magnetic intensity. So suppose we have a material or object with n turns of wire wound over it, and we have current I flowing through each turn. Okay, so current flow I flowing through the wire. So magnetizing force or magnetic intensity is the number of ampere turns of current flowing through unit length of the material. So basically it is the product of the number of turns and the current flowing through that wire. Okay, so magnetizing force or magnetic intensity, which is expressed as capital H, is equal to Ni. SI unit is ampere turns per meter or ampere meter inverse. Okay, so there is a relationship between the magnetizing force and the magnetic flux density, which is B is equal to mu Ni. So here magnetic flux density is equal to the permeability multiplied with the magnetizing force or magnetic intensity. This is also an important relationship. So first, magnetizing force is equal to product of the number of turns of wire multiplied with the current flowing through the wire. Then the magnetic flux density, capital B, is equal to permeability mu multiplied with the magnetizing force or magnetic intensity, capital H. So here three parameters which we have discussed until now: magnetic flux density, magnetic permeability and magnetizing force, they are interrelated by this equation. Okay, so this is magnetizing force or magnetic intensity. Next is intensity of magnetization. So whenever a magnetic material is subjected to a magnetizing force, it is, it gets magnetized. Now, how much the uh, the material gets magnetized, it depends on the magnetic moments developed in that material. Okay, so we have discussed about magnetic dipole moment. So basically magnetic dipole moment is the product of the pole strength multiplied with the distance between the two poles. So this is a very simple representation of a magnetic dipole, where the magnetic dipole moment is the product of the pole strength m multiplied with the magnetic length 2L vector. So intensity of magnetization basically is the magnetic moment developed per unit volume of the material. Suppose this material is subjected to magnetic field. Okay, now how much magnetic moment developed in it per unit volume, that gives us the intensity of magnetization I, which is a vector which is the magnetic moment per unit volume. Okay, now for a magnetic dipole, intensity of magnetization is the magnetic moment, which is m into 2L. This is here is not cross product, this is simple multiplication divided by the volume of the material. So here A is the area of cross section of this material, 2L is the length, so volume is A into 2L. So m into 2L magnetic moment in the numerator, A into 2L volume in the denominator. So that is equal to 2L cancelled, it is small m by small a. Okay, this is the intensity of magnetization for the magnetic dipole. So simply intensity of magnetization I is the magnetic moment developed in the material per unit volume when it is subjected to an external magnetic field. Okay, so this is intensity of magnetization. Next is magnetic susceptibility. So magnetic susceptibility indicates how easily the material can be magnetized. Okay, so it is the ratio between intensity of magnetization, which is the magnetic moment developed per unit volume, and the magnetic force or magnetic intensity. Okay, H, which is equal to Ni. So the ratio between intensity of magnetization and magnetic force and intensity, that is expressed as magnetic susceptibility. Okay, this is the magnetic susceptibility. Okay, so here I and H, they have the same units, ampere meter inverse. So this ratio, it does not have any unit, it is a number. Now relationship between relative permeability and magnetic susceptibility. So there is a derivation part to this. I have not gone into that part because we are not discussing it in detail. I just wanted you to refresh those concepts that are important. These concepts you have already studied in in the +2 level or 11-12 level, in the high school level. So just to refresh your concepts, I wanted to discuss it. Otherwise I would have gone in detail, because these things will come up in our discussion related to electrical machines. So I have not gone into the derivation part, I have simply stated it here. So the relative permeability, magnetic permeability, is equal to the magnetic susceptibility plus 1. Okay, that is the relationship between the relative magnetic permeability and the magnetic susceptibility. Okay, so here we have discussed in a very quick manner all the important parameters related to the electromagnetism or the magnetic effects of electric current. First, magnetic flux density and magnetic flux, then magnetic permeability, then we discussed about magnetizing force or magnetic intensity, then intensity of magnetization, then we have discussed about magnetic susceptibility. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.